Welcome back to Cloud 42, I'm James. Today we are continuing work on the Toolpost grinder. This is going to be part 18. If you haven't seen the other parts of this video series, there is a link to a playlist down in the description. Today we're going to start working on the grinding wheel arbor that's used to hold a 4" by 1/2" inch grinding wheel in the spindle of the grinder. Let's go over to the bench and take a look at the plans. Okay, this is the arbor that we're going to make. You can see that it's got a 1/2 inch arbor with threads on the end on this side with a flange, and on the other side it's got a taper. Now the arbor side with the flange is meant for a 1/2 inch thick grinding wheel with a 1/2 inch hole in the center. And I've already tested, and a 1/2 inch pin fits pretty well in the center of this. There's not a lot of free play, so I think 1/2 inch is going to be the right diameter for this arbor. So then the wheel goes onto the arbor, and then there's a flange that screws on to those threads on the end. And so this is just, 200 thousandths thick with a threaded hole in the middle and a couple of pin spanner holes to be able to tighten it down. Same thing here, there's pin spanner holes in the back. And so we can put this together with 2 pin spanner wrenches, or we can build a fixture to drop the taper into with pins to hold this while mounting the wheels. Okay, so I've thought for a while about the order of operations to form this. And the trick is, if you start too soon on the taper, then there's no good way to hold on to it while machining the rest of it. So I think what I'm going to do, I have a tap for the threads, and I'm going to single point the threads on the outside here. So I think I need to make the flange first so that I have the holes at least threaded so I can use it to test and fit these threads so I don't have to mess around with wires, thread wires. And then to get everything running true and concentric, because this is going to be drilled, I'll probably bore it, but the tap even so may not be perfectly concentric. I'd like to mount this on the arbor to actually turn the outside diameters. They're not critical diameters, but again, this is going to be spinning pretty fast, and I want it to spin as true as we can get it. So I'm going to make an aluminum spacer with a 1/2 inch hole in it that's 1/2 inch thick that we can just drop into here and then screw this flange down onto the arbor and then finish both of the outside diameters at the same time. And then once that's all done, we'll flip it around and actually hold it by this threaded end in a fixture to form the taper and the drawbar thread. This is the material that I'm planning to use. This is 1.5" round 1144 StressProof steel. This machines fairly well, even on a small lathe, and it should be very stable, meaning it shouldn't move around very much as we remove material from it. So I think I'm going to cut off a piece of this that's long enough to form both the arbor and the flange. Then we'll face the end, slice off a piece, make the flange out of that, and then use the rest of it to make the arbor. Let's go over to the lathe and get started. Okay, this is the material. This is 1.5" 1144, and I've got it cut to length. There's enough material here to make both the arbor itself and the flange, the outer flange. So the first thing I'm going to do is just face this so that I have one face that's definitely perpendicular to the cylinder, at least close enough. It's a 3-jaw chuck. And then we'll slice off a piece in the saw and use that to make the flange. Make sure I'm on center here. Might be just a touch high. There, that looks better. Okay, we're running in 1200 RPM just because if I ran 2400, which is my only other faster choice, I'm going to be over speed for the outer side of this. Let's see how the 1144 cuts. Yeah, looks pretty good. In fact, that's really nice. Now, I'm going to run over the saw and cut a piece of this off that's long enough to make the flange. I'll be right back. Okay, there we go. Got a 200 thousandths thick slice. Actually, it's about 260. Measured around the sides. Saw, I've just got a little Harbor Freight 4x6 saw. It's cutting pretty straight. 262, 259, 256, 259. This is the thinnest spot right here. 258, 257. I'm pretty happy with that. Okay, so I've got this side faced and perpendicular to the outside diameter. Now in the end, this side is going to be facing out, so this is not a critical, I mean, I want it to run true, but this is not a critical surface. The registers are all going to be on this side. So I'm going to go ahead and mount it in here with parallels. And then we'll face this side, drill and tap, and then cut the register in this side of it. So that'll all be perfectly parallel, or perfectly perpendicular to the threaded bore. I much prefer not to use parallels for this. I much prefer a lathe spider, but in this scenario, this is kind of my best option because I'm going to have to drill through it, and I don't want to drill into the lathe spider. Okay. Okay, that's tight. The reason the parallels fell out is because the jaws rock slightly and the tips come forward. But it should be pretty straight. Let's see what it looks like. Okay, the first thing we need to do is face this off to exactly 200 thousandths. And so to do that, I'm going to bring in a dial indicator. Okay, and we'll just call whatever that is 0 right there. Okay, so we're right about 10, maybe a half. Let's see how thick we are. So let me just go ahead and 0 it right there. Okay, thickness right here, 246. See how straight I got it. 244, 243, 244. So we're about 244. So I got to take 44 thousandths off of this. Let's take 20. And then let's take 15 more. And then let's take the rest. I'm not even going to measure, just going to go right to 44. And take this nice and easy and get a good surface finish. That looks nice. Let's see how close we came. 201, 201, 200.5. I can definitely live with that. Can you see that there? Yeah, you can. Okay, so that's faced paralleled within a thou, and to thickness within a thou. And so the next thing we need to do is drill and put a hole through this for tapping. Grab a drill chuck here. And let's go ahead and just center drill this. There's a good center. Now let's see, we want to bore to 453 before we tap. So, let's see, what size drill should we use? Let's just start with a 3/8. Let me grab one. Okay, there's a 3/8. And I'm going to slow this down a little bit. Go ahead and take it down to 560. And let's put a hole through that. There we go. And let's grab a boring bar. Okay, I'm going to take the speed back up. Zero out all my dials here so I know for sure exactly where I am. Okay, let's see where we are. It's like 387. Let me make sure. It takes less time to measure twice than it does to make the part twice. 387. And as usual, I will be using my calculator. So we need 66 thousandths to go, divided by 2 is going to take 33 thousandths off of each side. So I'm going to take 10, and let's see, where's our feed set to? Okay, C1, which is 3 thou. Let's try that. Let's not auto feed this. Let's take another 10. See where we are. We're at 422. Headed for 453. Means we have 31 thousandths to go, or 15, which is just about where we thought. We'll take another 10. $441. It's like about 441 and a half. Which means when you take another 6 thou per side. I'm going to take 5 because I know there's a little bit of spring and this is a smaller cut. And this is just the bore for threading anyway. So if we end up slightly off, it doesn't matter that much. Okay, let's see where we hit. It's like 453, right on the nose. Okay, well that makes me feel good. Carbide in steel and I didn't screw it up. Okay, so we've got that. Next thing we need to do is tap it. Put a tap through that hole. Actually, you know what? I think before I do that, I'm going to go ahead and run the register in this. And let's start by marking it. I'm going to use the boring bar for this. And again, the dimension on this isn't super critical, but we're at 1.5 and I want the dimension of the recess in the face of this. Look at the drawing here, says 1.2, which means I'm going to bring it up here and I'm going to bring it flush with this edge. and then I'm going to run it in 150. So there's 150. I'm going to go 5 thousandths in off of that and make a little mark. I'm going to put a little mark here on my dial as well. Now the surface here, I need this to be 15 thousandths deep. So there we are on 0 on the dial. We'll take it to the center and we'll want to run it in ultimately to 15. Let's start with 5 and just see how it goes. Okay, we'll take 5 more. And the last 5, and this time we'll pull it out at a 45-degree angle. Okay, that's not awful. Okay, I'm going to put a little bit of a chamfer on that. I'm not going to bother with turning it. I'll just use this Noga rotary countersink. Okay, then I'm going to use a little paper and clean that up. Okay, nice. Let's grab a tap, put it through there. Okay, for tapping, of course, I'm going to slow it way, way, way down. Yeah, that should be 150 RPM. Yep, nice and slow. Okay, this is a 1/2-20 spiral point tap. High-speed steel. And it should be a H3 limit. So it should make a nice tight thread. And I'll just lube it up. And we'll go nice and slow. till it spins, and then finish it by hand if needed. Nope, went right through. Okay, one more little pass with the deburring tool just to clean up the edge of the thread. And I think that's going to be it. Okay, that looks beautiful. That is going to be it for this part for now. So eventually we'll put holes in the back. We're going to do that later. I don't want to switch over to the mill right now, but we'll form the other part of the arbor, and then we'll put this on and then do the outside with this actually spinning on the arbor. Okay, before I put the arbor in here and actually start making it, I'm going to want to do that all in one setup so that I can turn it down to diameter. And I mean, this is the material, so I can turn it down and actually form the stud and thread it, and then put the flange on the outside on the threads, tighten it down on a spacer, and then machine the outside diameter so it's all concentric. And I want to do that in one setup without taking it out, which means I need to make the spacer first. So I've got a piece of 6061 aluminum here, and as it turns out, I already made a spacer, and I filmed it and everything, but I'm not going to make you watch that, because by the time I got done with the whole thing and then checked it to see if it would fit, I realized that I made it out of 1¼ inch material. So that was a mistake. So I went back through my bin. It needs to be 1½ inch so it'll fit on the register, and I found a chunk of 1 5/8 inch, and that'll just have to do. So I'm going to start by facing the end and turning down a chunk of the end of it to 1½ inch. Doesn't have to be really precise, so let's just see where we are. 1.542, so another 42 thousandths. There's 21. Let's see where that puts us. 1.501. 1.502. So we're at 1½ inch. That'll be just fine. Let me go over to the bandsaw and knock a chunk of that off. You know, before I do that, I think I'm going to finish all the operations that have to happen on this end. So let me just take the sharp edge off of that. And then I need to drill a 1/2 inch hole through it, at least through the 1/2 inch thickness. And we're right now 1/16 of an inch longer than we need to be, so we should be just fine with that. going to take the speed down quite a bit. Let's take it down to 720. Just because that's as far as I can take it without changing to a different size belt. Okay. Start with a number 3 center drill. And just pop a little starting hole here. Put in a hole here. This is just a little over 1/4 inch. I didn't really look to see what size it was. Put a little A9 on here. And I'll try to stop from the camera from shaking. Sorry about that. So there we are. Now let's go a 1/2 inch. 1/8, 2/8, 3/8, 1/2 inch, and I'll go an 1/8 further. Now I'm not particularly worried about the diameter here, at least not enough to bore it, so I'm just going to grab a 1/2 inch drill. And we're going to go right to size. Or as close as the drill gets us to size. Again, put some A9 on here so the aluminum doesn't weld on. Okay, there we are. 1/8, 2/8, 3/8. There we go. I have to say, after working with that W1 tool steel, aluminum is just a joy. What do you think? Can we part this? Let's find out. Probably way too fast, but we'll find that out too. Well, I don't want to push it. I'll just take this over to the saw and just knock off that piece. You guys stay here. I'll be right back. Okay, there we go. Cut it off on the saw. Oh, got a little bit of a lip there. I didn't think to take care of that. Okay. So I want to flip this around and face it to exactly a 1/2 inch thick. But I hate parallels, so easiest way to do this is with the lathe spider. Flip it around. Insert joke here about the new dead blow hammer. I got this specifically to use on the mill after I got some complaints on my in the comment section about using the vise handle to tap parts down in the mill. I had a bigger one and it was just too much, so I was grabbing the vise handle. But now I have a proper sized one. Okay, go back to carbide. And just like I did last time when you didn't get to see it, what I'm going to do is bring this over and just touch the back of the lathe spider and zero my dial indicator. So there I am at 0. So 100, 200, 300, 400. So that's 500 thousandths right there. And so it's one turn in from the end of the dial, and I'll just turn it to thickness. Okay, that should be ½ inch. Oops. Okay, and let's chamfer the outside. I think that is it. Now, first thing, are we really 1.5 inches? Yes, much, much better. Okay, second thing, let's check the thickness and see how close we got. .498, 498. 498, 498. Okay, this one's 498. Last time, when you didn't get to see it, oh, it says about 498. Yeah. Yep, 498. Gonna call that good. We'll set this aside until we're ready to use it.